All right, everyone, welcome to week 2, day 1, even though it's Wednesday, of Computer Science 41. We are going to continue our exploration of proper class design. So, and again, there's double quotes around proper class design because everyone's got their own opinions about it. There are some things that you kind of need to know, though, and we're going to go over that. So, let's say that we are going to make a class that represents a die, like a D6, a normal 6-sided die. Okay, let's go ahead and make that real fast. Main.cc, shoot, it's got stuff in here. Move main.cc to fraction.cc to main.cc. Okay. So we're going to make a class called die, not to be confused with a die function that kills your program. Okay. So by default, everything's private. So what kinds of things should a die have? Like, what describes a 6-sided die? Or actually, let's maybe say maybe it's not a 6-sided die. Maybe this can represent any kind of dice. So there's I can think of 2 things would describe a die. Maybe more. What can you guys? What kind of D&D player am I? How do I not have a die within like arm's distance of me? This is crazy. Okay. When I recarpeted, I put all my D&D stuff over there. Normally, I would just be able to reach over and grab a die. What describes a 6-sided die? You guys all know what I'm talking about? Or D&D dice. There's lots of different kinds of dice, right? So just look at it. I mean, like, this is how you start by designing a class. This is the mental process you go through. You're going to make a class that will, I don't know, be a dice roller or something. There's a lot of those online, but, maybe you're making your own. A lot of, if you take gaming with me, the game design class with me, you're going to probably implement a dice roller at some point, and maybe you'll have different dice and things like that. Maybe people could upgrade from a D6 to a D8, to get a higher score. So just looking at these things, what describes them? In amount of constant unique integers, lots of dots, cube, a vector for sides, which can be created with an initial input of integer, number on its face, random numbers, random element, numbers 1 to 6. Yeah, the random element. So there's 2 things that go into a type, right? There's 2 things that go into whenever you make a new class. There's 2 things. The first is what kind of state it has, like what actually describes a dice here. And so one thing that you guys didn't mention would be like colors, right? Like you can have a green die, or you can have a black and blue one, or a purple and white one, right? So I mean that's something that describes the state of the die. That's a blue die, that's a gold, it's metallic or not. Like I'm probably not going to implement that, but that's something that could describe a die. And then the other thing is there's nouns and there's verbs, right? So whenever you make a class, nouns and verbs are the 2 things. Nouns are things that it is. How many sides does the die have? What color is the die? What numbers are on the faces? Right? Because normally if you have a 6-sided die, the numbers go from 1 to 6, but it doesn't have to be. Like for a 10-sided die, the numbers can go from 0 to 9, or from 10 to 100. So the range of the die, yeah. And so there's the state, the thing that physically describes, the dice, and then there's the verbs, which are things you can do with it, right? And so the random element is something you can do with it. It's a verb, right? Rolling the die, essentially, right? Like, now if you're talking about like if you want to do weighting of the dice, like if you want the die to not be fair, then that would be state, right? Like if the die, if you could put a weight into one of the corners and so it rolls on that side more often than another one, then that would be part of the nouns. This side is more likely to come up than another side. But the verbs, what can you do with a die? Well, you can roll it, is the obvious one, right? So it's going to need a roll function on it. Verbs become functions, and nouns and adjectives become, you know, the member variables, right? What color? That's an adjective. Sorry, I said noun, but adjectives and nouns. Like what numbers are on the face? You know, what color is it? You know, those are the member variables. And then what things you can do with it are the member functions. Member functions, the verbs, the things you can do with it, those are oftentimes public functions. Roll the die. Another thing you can do with it is look at it to see what's on top, right? Because maybe you roll the die and then you might want to look at it again in the future. So, yeah, that's about it for the verbs of a die, I guess. Destroy it, I don't know. Hit it with a hammer. Okay, so the first thing you do when you make a class is, you know, first think about what kind of state the thing, whatever thing it is you're making, can have. It is like nouns and adjectives, right? And these things become private member variables, by and large. Okay. Second, think about what you can do with the thing. The verbs. And if I'm confusing you with my crazy English skills, well, it's because you're looking at an English minor here. Yeah. Not even quite a minor. That was an area study. It's one class below a minor. Just not worth anything. And so these things become your member functions, usually public. Okay. If you need something to be done with the die that only the member functions need, then those become private member functions. But anything like a user of the die would use, like a user would be a person in a bar throwing a die, right? That would be a public member function. Okay. All right. So let's do this. So first thing I would have is sides. Okay. And you can do this, by the way, in modern C++. What's the mail command on the server again? The mail command on the server is called Alpine, and that'll tell you what grade you got on the last homework assignment. Technically, you could send me an email on there, but I won't read it. Alpine, yeah, Alpine. I think it's like alias to like something, P, maybe. Okay, so that, and then we could have like color. We could come up with some sort of like enum. I don't know if you guys know what enums are. Enum is a way of making a lot of constants at the same time. So we could have black and red and gold and stuff like that. I'm not going to worry about color right now. So one of the students, Arrow Storm, who is that your actual name, Arrow Storm? Make sure that your username on Discord has your actual last name in it. Okay. And if your last name is Aerostorm, I apologize. So suggested we have a vector holding what numbers are on the faces. And this is actually a really good idea because if you've ever played like Mario Party, in Mario Party, the dice. Has anyone here played Mario Party? Out of curiosity. Aaron, I got it. Yeah, you gotta have your last name though in it. So in Mario Party, the dice are not normal dice. Let's see. Yeah, so here are the dice that the different characters roll in Mario Party. And so I play as Bowser all the time. And so 2 of his dice results cost you three coins. And then the other ones are 1, 8, 9, and 10. So Bowser, half the time, gets a really bad result, and half the time gets a really amazing result. And so he's a lot of fun to play as. Peach gets 0, 2, 4, 4, 4, 6. Luigi gets 3 1s because Luigi's garbage. And then 5, 6, 7. So, all of these, Diddy Kong, 0, 0, 7, 7, 7. And so some of them are very predictable, very regular. 3, 3, 3, 3, 4, 4. Right? You're always going to get a 3 or a 4, and most of the time you're going to get a 3. So this is slightly better than an average D6, I guess. But if you need to get a 3 or 4, that's a good roll to roll. So anyway, so we can implement something like that. Now, I'm going to keep that open on my screen over here. Okay, so we will have a vector events called. Actually, we don't need this anymore. Look at this. We call this sides. Okay. Because the size of the vector will be how many sides the block has, right? So a default D6 would be 1, 2, 3, 4, 5, 6, like that. And then if we ever want to know how many sides the die has, then we can just call sides dot size. Sides dot size. Okay. Anyway, so this is then the private section, right? We don't need to write private because classes default to private, right? So you can just leave that off. We'll now do a public section. Is there any other state we should keep track of? Color, if it's been destroyed. I know. Int top. What number is showing on top? Right, because it may very well be that you're playing like a dice game. So you roll the dice, and then maybe it's like Yahtzee or one of these games where you can like pick up some of the dice and re-roll those and leave the other ones on the table. And so if you do that, then you need to have this thing retain its state. It needs to remember, hey, I have a 3 sitting on top or whatever. And if you do this, by the way, if you see where I say int top equals 1, that actually is part of the constructor. So if you do this, this will actually add code to the default constructor and actually every constructor. And so this was added in modern C++, and it's really nice. I like doing this because it just prevents you from ever having an uninitialized variable, right? Because every constructor will default to top being 1. Wait, make Farkle. Oh yeah, weights. Yes, thank you. Yeah. Yeah, Muya was in the Farkle group. That was funny. We can do it in this. We can do it in this class. And for weights, we can just, I don't know, set all the weights to be even or something like that. Okay. So, Mario Party is a great game. I don't know if I'd go that far, but it's definitely fun. I can definitely play with my kid. Courtney's comment on your assignment was looks cool but doesn't work. Yeah, it's not alone. You're not alone. Okay. So, proper class design. Okay. Constructors. Constructors initialize the class. And they have the name of the class, no return type. If the constructor takes no parameters, it's called a default constructor. A default constructor gets called if you make a variable like this. If you say like die d makes a standard 6-sided die. Right? And it calls the default constructor. But wait, you say, the default constructor isn't doing anything. Well, yeah. It is though. All this code here actually gets, all of these equal sign things here, they get copied into, the default constructor. So this is going to create a member variable named sides and initialize it to 1, 3, 4, 5, 6. It's going to create a member variable named weight, of type vector events name, and all of its weights are going to be set to 1. It's going to initialize top to be 1. So all that stuff actually takes place within the default constructor. You could not do this, though, by the way. You could not do this prior to modern C++. This was added in modern C++ 10 years ago. So if you have the unfortunate, I should say, to go to a college that doesn't use modern C++, then you'd have to put that in here, right? You'd have to do top is equal to 1 in here. And then in your next, in all the other ones, and then in the next constructor we're going to take, where we initialize it with a vector events named new vec, then we would also have to say vec equals new vec, and we'd also have to say top equals 1. You see that? You would have to put top equals 1 into every constructor. But because, who's calling me? But because we have it here, we do not need to do that. So we can just be like, nope, it's all good. Nope, it's all good. It's really nice. Saves a lot of typing. Otherwise, you'd have to copy those things, over and over again. Because sometimes you'll have a lot of different constructors. And so, I don't know, vec, yeah, size is equal to new vec, and let's see, how should we do this? Weight is equal to vector of ints of size new vec dot size, like that. So this it's kind of funny. And then we'll say for every integer in weight, set it equal to 1. All right, so this is some clever stuff I did right there. But the upshot of this is that if we come down here and we make a die D2 that is let's make a Peaches die 3 3. Oh wait, no, who's the person that had 3 3 3 4 4? Daisy, I think. Okay. I think that's Daisy's die, right? In fact, let's call it Daisy. Okay. Okay. So I'm passing one parameter. I'm passing one parameter to the constructor here. And so C++ says, is there a one parameter constructor? In other words, a constructor that has one parameter in between the curly, or not curly braces, the smooth parentheses. Okay? And C++ goes, yes, there is. You might notice that when I did it a different way, it didn't like it. So we'll talk about the difference between smooth parentheses and curly boys in a bit. But basically what this is going to do, C++ says, is there any constructor, because I'm passing one parameter when I make this variable. Yes, there is. Okay, can I convert this into a vector of integers? And C++ goes, yes, I can convert that. This thing here is called an initializer list, and vector has a constructor that takes an initializer list. And so C++ says, can I build a vector of integers using this thing right here? Like, you see how that works, right? And C++ goes, yeah, I can. So it will pass this data in here. It copies all these values, go into sides, and then it will make a new weight vector of size 6. because there's 6 elements in it. And then it goes through every element in weight and sets all of them to 1. Like int Daisy would be an int named Daisy. Does Daisy need to be initialized? How does it know what Daisy is? Daisy is, you know, I still have the thing up here, right? Is this, we're making this die right here, right? That's 3, 3, 3, 3, 4, 4, right? And so this line of code here is making a variable named Daisy of type die. It's a dice. A singular dice is called a die. And then it passes to it it passes to the constructor for it 1 parameter. And that parameter is, for all intents and purposes, a vector. It's not actually a vector, it's an initializer list. But C++ understands how to convert from an initializer list into a vector, so it converts it into a vector for you, and then it runs this code here, which will copy, it essentially copies this data into that. Okay? Your memories of Mario Party are a blur. So, can't do curly brace initialization on private members. Got to use that constructor. Well, what's actually going on there is if you use curly brace initialization, it has to be like an exact match on the type. So if you saw what I did the first time, right? I did this. And so what Mui is talking about is that if you have a struct, C++ will actually generate a constructor for you that will allow that to work. And so if this was a struct, like a plain old data, pods, it was like class die and it was just this public, nothing else, no constructors, none of that stuff, then this code would actually work because it would copy this into this. But what's going on here, the reason why this doesn't work is because when you use the curly braces, it only does an exact match. You see what it says here? No matching constructor found for die. So even though I'm passing in 1 parameter, the types are different. This thing here on the bottom of the screen, the 333344, is an initializer list, and my constructor only takes a vector. So that's actually not an exact match on the type, and it will not convert for you. So a lot of people prefer using curly braces all the time so that you don't get accidental conversions when you don't want them. And so if I wanted it to work this way, then I would have to say vector of int, like that, and then it works fine. So I build a vector of integers who's initialized to 333344, and then that gets successfully passed in here. Okay. So and then I could do this as well. And you see that the curly brace initialization works now because it's the proper type. Curly brace initialization, the type has to exactly match the constructor. With smooth parentheses, it'll do a type conversion for you. So let me write that down. Type Daisy. Actually, let's make a different one so I don't have variables of the same name. Which guy do you want me to make? Or girl do you want me to make? Which one? Bowser? I can't make Bowser because some of his die values are not integers. I guess they are, -3. I guess probably special case that. But we would probably need another thing added up here to handle gaining coins and losing coins. Shy guy? Dry bones? Shy guy? Again, we can't do anything that loses coins. I'm just going to ignore that complexity right now. All right, dry bones. Dry bones it is. All right. And his is 111666. Okay. My daughter's very concerned that I always play as Bowser. I'm like, it's not because I'm evil, it's just because I'm a big dude. And Bowser's the biggest dude out there, other than Donkey Kong. Okay, so there we go, dry bones. And so this works because parentheses will convert types. This works because requires exact types. So that's the difference between constructing something using smooth parentheses. Another way I could have done this is just this, like that. Those two things are the same thing, basically. Do you guys see the difference? I've got a smooth parentheses there, and I've got a curly boy there. So if you use smooth parentheses, it'll do a conversion for you, a type conversion for you. If you use curly boys, then it will not. And so you have to make sure your type matches exactly. A little bit of C++ trivia. But a lot of people out there only use curly braces for initialization because they don't want to accidentally convert to something that they weren't intending to. Like, what if we made a thing that takes in a string, and all this constructor is going to do is like, hey man, you shouldn't be passing in a string to a die. That makes no sense. And you can do this. I mean, I don't know why you would, but you can do it if you wanted. Output the string. Okay. And so look what's happening now. The bones constructor is ambiguous. There's now two constructors that could match. It's like, what? Huh? Huh? But this one works fine, right? Do you see? You're like, how the hell is a vector of integers? It's not a vector. How the hell is a vector of integers matching this? Right? In fact, if we commented out this code, it would say, hey man, you shouldn't be passing a string to a die, and you just be like, WTF, man. In fact, let's do that. It'll be funny. You see what I mean? That's why a lot of people like curly braces, because you're just like, that shouldn't have happened. What the hell keeps calling me? There. It's my mom, and she should know I'm in class right now. Hey man, you should be passing a string to a die. That makes no sense. That makes so sense. Fantastic. And then the string that it prints out is that. Are you guys familiar with ASCII at all? ASCII is the American Standards something interchange format or something. So anytime you have a letter, like a basic letter in computer science, it is converted to ASCII. Those numbers are treated as ASCII. The trouble is all the numbers that we have are down here. And so it was sending the end of text character, which isn't used for anything. But like if I wanted to print hello world, 72 is H, 69 is E, and 76 is L. So it's treating those numbers as if they were characters in a string. And so it is initialized in a string with 3, or what was it, dry bones, sorry, so 1, 1, 1, start of heading, which I don't know what the hell that means. 1, 1, 1, you know. And so if I wanted, I could get it to print hello world 72, 69. Everyone remember this. 72, 69, 76, 79. It's like lost. The numbers. 72, 69, 76, 79. Okay. We're getting a little bit off topic right now, but it's funny, so we'll do it. I'll just save the original so I don't lose it. Okay, 72, 69. What was the next one? 76, 76, 79. There you go. And so it's printing hello to the screen. Okay. So I know this is a little off topic, but it kind of shows you why people actually prefer why people actually prefer the curly braces, because when you know, because this looks like a vector of integers, right? It's integers. Nope. Guess what? Characters, the letters you print to the screen, are integers. They're 8-bit integers. And what you got here, a bunch of 8-bit integers, and yeah. So it did not know whether or not it should be matched on a string or on this one. It's ambiguous. Okay. So it's good. Erase that monstrosity there. So anyway, so that's why. Yeah, that's fine. I'll just delete. Yeah, I'll just delete it. Okay. But if it's not ambiguous, then you can do whatever. Okay. But there are weird conversion things like that in C++. The technical term for it is a foot gun. A foot gun. A foot gun is a part of your code that lets you shoot yourself in the foot. Okay. And you'd be surprised what things convert to what things. Like you could say this. Watch. String s equals 0. Let's just initialize it to 0. Let's see what happens. Let's see what happens when you initialize a string to 0. It dies. It kills your program. It crashes. What just happened here? So this, in my opinion, C++ should not allow strings to be set to integers. I don't think that should be in the language. I'm sorry. I don't think that should work, but it does. And so if you want to crash your code, setting a string equal to 0 is the best way of doing it. And a lot of people just get into that habit of initializing everything to 0. You know, they're like, int x equals 0, double d equals 0, float f equals 0, string s equals 0, and then their code explodes. And they're like, what? It shouldn't compile. If you die in the code, you die in real life. Yeah, it's like Jumanji coding style. Yeah, and the reason why it does this is because it treats this as a memory address. It treats this as a pointer. So it is treating the 0 as a memory address, and it converts from int to pointer, and string takes a pointer. It's supposed to be pointing at another string, a C-style string, and copying the data in. But what happens is like, oh, 0, that's a pointer, and then it goes to that memory address and tries reading it, and it crashes because you can't read from memory address 0. I think that's maybe a bad idea in the language. Like maybe that shouldn't be a thing. I don't know. It's there for backwards compatibility, but it's really dangerous. All right. So that's why people like curly braces. All right, let's move on. So we'll need another constructor. The other constructor, is it trying to read null? Yeah, 0 is null. So yeah, so it interprets the integer 0 as a memory address, and then it tries going to that memory address to read a string, and there's no string there. It's at the memory address 0, which is inaccessible, and crashes your code. And students get very confused why that happens. I get very confused when I do that by accident too. Not often, but sometimes I'll have like a templated thing that initializes things to 0, and it'll crash when you pass a string to it. All right, so we'll need another constructor that will take vector of ints, new back, vector of ints, weight, new weight. New weight is what you call being in quarantine. Sad because it's true. Okay. Sides is equal to new vec. So this is called a default constructor. This is called a 1-parameter constructor. This is called a 2-parameter constructor. Okay. So if you pass in 2 things to it, it's going to call this bad Oscar right here. Okay, so sides is equal to new vec, and then weight is equal to new weight. And we'll just leave top as 1. Numbers, oh, maybe we shouldn't do that. Yeah, maybe we shouldn't do that. Top is equal to sides dot at 0. Ooh, what if they pass in an empty vector? Let's talk about that in a second. Okay, so let me just show you how the two parameter constructor gets called. So let me make a die called D4. It'll be a 4-sided die. And so the first parameter will be the value of the dice, 1, 2, 3, 4. And the second value will be the weight of the dice, 1, 1, 1, 1, 0. So the number 4 will never come up. It's a busted die. It cannot. The number 4 can't come up. Okay, you guys see that? There's a comma in the middle here. So the first parameter is the numbers on the faces of the die, and the second parameter is the relative weights of the sides. And so the die is broken, it's got a curved surface on the bottom, and so the 4 can't roll. Empty parentheses is the default constructor. Yeah, if you wanted, you could do this. If you wanted, you could do this. That works, I guess. Maybe not. Nobody writes that. It's a warning. Yeah, the most vexing parts, right? So, yeah, so you don't need to just leave it off. The first constructor is the default constructor. Yeah. So default constructor, yeah, 1 parameter constructor where it takes one parameter, like this. This looks like you're taking more than 1 parameter, but it's, see the curly braces around it? This is actually 1 parameter being passed in. That's a vector being passed in. And this one takes 1 parameter. Also, it's taking in a single vector. It's just doing it explicitly. Again, we use the curly braces to avoid footguns, right? Where you pass in an integer, the integer converts to a string, and then it explodes your code, right? Like, try to use curly braces. General good practice. Couldn't you make one function as 3 parameters and 2 of them are initialized? Sure, yeah. And I'll show you guys how to use defaults in a second. And then this guy here is a 2 parameter constructor. So it takes in 2 vectors, and it's going to copy 1, 2, 3, 4 into sides, and it's going to copy 1, 1, 1, 0 here into the weight. And so, do you guys see how this works? Like, this is how you make a class, right? You have to think about all the different properties the thing would have, all the different state that it might maintain, and then you make constructors that initialize them, that are public. I'm not going to worry about the 3 parameter constructor. And I'll do it. It won't take long, because I'm going to show you the super cool way of doing it. And so, and top equals, let's not get ahead of ourselves here. Sides equals new vec, top equals, I'll show you another trick. This points to top equals top. So some people code this way. Do you see where I said this points to top equals top? This is a very common idiom in C++ as well. So rather than having to come up with new underscore or whatever, or coming up with some different parameter names, weight equals new weight, whatever, they actually like naming the parameters after the actual member variables. And then this points to top means my top, so this guy here. And this top refers to this top. And so you have this points to top, who is your member variable. That gets set equal to this top. And I don't like teaching it that way, because a lot of students forget the this. And they just write top equals top, and they think that this guy's been set, but it's actually setting that guy. And I'm not really a huge fan of it for that reason. Because top equals top is perfectly valid C++ code. It just doesn't do anything, right? So I'll leave that in there for you guys to look at because that is something that people do. Okay, so will I be able to go back to this lecture in a couple hours? Is it posted much later? It takes a couple hours to upload. You can general, but on a constructor. Okay, so let me show you the super cool, awesome way. So you see how I have 4 different constructors here? 1, 2, 3, 4. You guys see that? 4 different constructors. It can get fairly verbose, right? If you have, and this isn't even this is a die. Like it's not even like that complicated. You can actually end up having and lots of the code gets copy pasted, right? You see how like that line of code appears in 3 different places, right? There's got to be a better way, and there is. Let me show you. So I'm going to start off mx sets a mark named x in vim mx d single quote x, and it deletes down to that mark. That's a way you can easily delete things. Oh look, because I deleted all those constructors, everything broke down there. Look at that, cool. Now let me show you about default parameters on a function. Some people hate these things, by the way. Some people hate them with a passion. I think they're great. Because it allows you to not have to repeat yourself. I'll say it again. I'll repeat myself. You don't need to repeat yourself, right? So all that code that we had duplicated over and over again is now not duplicated. It's in one place. And I really hate copy pasting code because if there's a bug in one place, you're gonna have a bug in another place, and maybe you change it in the other place, but you don't change it in the first place, and the bug's still there in some cases. And you're like, haven't I fixed this before? And you fixed it in 3 out of the 4 constructors, and then it comes up again 5 years later, and you're like, I thought I fixed that thing, you know? Are you using an old version of the code? No, not the latest version. And so I really hate having duplicated code. And if you use default parameters like this, then what happens is if you don't specify anything, like this guy, right? Like this is calling the constructor. What that means is if you do not specify the parameter, it will default to this value. It will default to this value. In this case, an empty vector. And so what I really want is for it to default to 1, 2, 3, 4, 5, 6, I guess. And I want new weight to default to 3, 4, 5, 6. And then let's see, sides equals new vec. I should just call this new sides, shouldn't I? At this point. Sides equals new sides. And what if they pass in vectors with a different size? What if they put in a vector with a different size for sides and a different size for weight? We need to check for that. So if new sides dot size is not the same as weight dot size. So if they didn't pass in a second parameter, like let's say they passed in 4 people here and they didn't pass in somebody here, then weight is equal to vector events of size sides dot size. I need to say new sides at this point. And for every integer in weight, that integer is equal to 1. And then so this handles the edge case where they pass in a vector of size 4 for sides and not for weight, right? Because what if the user screws with you, right? And they pass in. What if the user screws with you and they pass in, something like this, where you have the weights and the sides don't match? So what this code will do is it'll just set all the weights to be 1, and it'll make the weights a vector of the same size as sides. I'll just set them all to 1. So this is a 1 line of code that will set all elements in a vector to 1. For each element in weight, set that weight to be 1. That's what that's what that code's doing. Yeah, you gotta think about all the different angles, right? You gotta think about all the different angles. Like Walker, who's making our attendance bot, his code crashed because he didn't consider that somebody could drop the class, right? And so when people dropped the class, they left the Discord, then the Walker bot, the attendance bot, would crash because he was trying to reference something that wasn't there anymore. And so his code was crashing as a result of that. It's always those things you didn't think about that really cause you the biggest grief. And when you're a computer science person, after a while you sort of develop an intuition for like, what could go wrong? You know, because you've seen it. You know, you've lived it. You've had your code crash on you. Okay. And so what's really neat about this is if you pass in, it's a possibility that top is not 1. I'm not going to worry about it for now. There is a bug there. Like, what if they pass in a die that's all 7s, and the top defaults to 1? 1's not a valid thing to show on top. Hell, I'll do it. No, I don't care. Oh, fine, I'll do it. It's annoying. All right, bool found equals false for every integer in weight. In sides. For every integer in sides, if x is equal to the value passed in as top. Because again, what if the user, you know, does this? They pass in a 4-sided die, and they say the top number is 10,000. 10,000 is not one of the dice, and so I don't want to allow that. I'm not going to allow that. And so what I'm going to do is I'm going to search through the sides vector and see if what they passed in for top is actually, it's actually printed on the die somewhere. So if for every die face, if what they passed in here is on it, then we'll set found to be true. And so this is one line of code that says search all the elements in the vector, and if you find it, set this flag, set found to be true. If found, then this points to top equals top. Otherwise, say otherwise. Why did they post the same? Otherwise, this points to top equals let's just make it the first element of the vector, sides dot at 0. And there's still one more way this code can crash, which is what if they put in a vector of size 0? Right. What if good, yeah, I'm going to notice that. What if they pass in an empty vector, right? Like what if they pass in this? Let's do die Bowser. Why are you sticking out your tongue, dude? And Bowser's just going to pass in an empty vector, right? So what's going to happen is call of overloaded die is ambiguous. Yeah. Vector of its. So I'm passing in an empty vector of ints, and if I do that, then the code crashes. The code crashes because it tried accessing element 0 out of an empty vector. Element 0 doesn't exist and it crashes. So, how should we handle this? What should we do if they try passing in an empty vector? Last time I saw her, she was like waist-high. Yeah, she's grown up. 8 years old now. Make the else if vec size is greater than 0. Okay. I would argue that we probably shouldn't allow it at all, right? A dice with no sides. I don't. Maybe even a one-sided die doesn't even make sense to me, right? Like maybe we should make a precondition, a class invariant that
Yeah. So what you do is you shape the ball of clay, and then one side you flatten.
there must be at least.
And then you put a 1 on it.
Yeah, ping pong ball's a one-sided die, right? There must be at least 2 sides. Okay. And the side of weight is the same side. The size of weight, I'll just put this on a different line. And the size of weight will match the size of side. Okay. So, how do we do this? How do we do this? Well, it's a good question. I mean, the most obvious thing is to say if new sides dot size is less than 2, see out. Sorry, bruh. No small dice here. I don't know. Whatever. And then, quit. So you can do that. You can do that. And that's, there you go. That's, that's one option, right? The way that I think most programmers would do it, though, is they would and I mean, there's different, maybe you don't want to quit your program if something like that happens. Maybe maybe just make it a default D6 or something. Like maybe you print a diagnostic message and then set the die to be a regular 6-sided die. Maybe, I don't know. But I think if you're going to just kill the program in that case, especially it's when you're writing the code that uses it, and it's not a user entering the number of sides of the dice and things like that, then there's something called an assert. And an assert just means make sure this thing is true. And so it's very similar to our die function. So you can say assert that the number of sides is greater than or equal to 2. Do you guys see that? So what does that mean? Okay. So if they pass in a, like Bowser down there that has no sides, this will not be true. And so it kills your program. So it's very similar to what we've been doing with die, except it's just one line of code. So it says, assert that the number of sides is greater than or equal to 2. And if it is, cool, and it will carry on. If it's not, bad, not cool. And it will kill your program. See? Assertion failed. Have you guys ever seen there you go, assertion failed. And it tells you what? How did it die? New sides dot size greater than or equal to 2 failed. It tells you on main.cc line 23. It's actually much more useful than our die function. Our die function just says bad input, you don't know where. Right? So asserts are the proper way of doing it. The reason why I use die is because the auto grader will match on die. This will not, I can't put that into the auto grader because your code's gonna be dying on a different line of code than my line. So that's why we use the die function. It's purely for the auto grader. The proper way of doing this is by using assert. And assert is, ironically, it's in a class called die. But yeah. So is that a function from the CAssert library? Yes. You hashtag include CAssert, and then that gives you access to the assert function. And the assert function basically says, make sure that's true. If it's true, it does nothing. If it's false, it kills your program. And so if you've ever played Bethesda games, you'll probably have seen assertion failed, 0. And you're like, cool, thanks for that utterly unhelpful error message. Assertion failed, 0. Because 0 is false, right? So if you have an assert 0 in there, if you just say assert 0, then that will always kill your program. Assertion 0 failed. Classic Bethesda right there. Okay. Is it normal to be confused by classes? Yeah. So all we're talking about right now so far, Duffy, is just making a class and initializing it. That's all we've done. That's all we've done so far in this class today. Like, we've really just talked about constructors so far. Okay. So, Min Curly wants the YouTube link. Are we full on the streaming? Okay, let me pull up the YouTube channel here. 1 second. I'm streaming, but I'll just give them the recording after it's over. All right. Let's see where we. Okay. So, a class. A class is, what is a class? It's your own type technically, so you can make variables of type die, and then it's got things that describes a die, and then these are this constructor here, and I know I showed you like 5 different things, but when you do constructors this way, you only need one of them, right? So you basically can have all of your parameters there, and you can give a default parameter. So if they do not specify, so what's happening here? Like, if you make a die like this, then it will have sides be a standard 6-sided die, because I didn't specify it, right? If you don't specify one of the parameters, it will use the default parameter. Do you guys hear that? That if you do not specify a parameter, it uses the default parameter. So if I make this die down here, then it's going to make a die that has the normal numbers on its faces. All the faces have a weight of 1, and the top of the die on the table is 1. Okay. And if I pass in one parameter, like bones, then this default parameter will not be used. That default parameter will not be used. Instead, new sides will be set to the parameter. It's like a normal function. When you have a function, you pass values into the function, right? And so this is a default value on a function. It doesn't get used because they passed in 111666. And so it will copy that vector 111666 into this guy. Okay. And so what happened was, yeah, I merged the default constructor and the 1-parameter constructor and the 2-parameter constructor and the 3-parameter constructor together. And technically, I don't even need this stuff up here anymore. You could consider leaving it there just as a safety measure. But once you have the omega constructor, once you have the ultimate constructor, you can actually delete all that if you want, just to cut down on the verbosity of your class. It's a design decision. It doesn't really matter. So here with Daisy is passing in a single parameter as well. So that also will call this with 1 parameter passed in. So new sides will be set to 33344, 3333, 333344, and new weight will be all 1s and top will be 1. This one here is the 3-parameter constructor, so it's going to pass in 1, 2, 3, 4 for sides. It'll pass in an invalid weight for weight, and so that code here will handle it. If you're confused by why I'm doing this, just remember, somebody doesn't, the people using your code don't have to follow the rules, right? It's up to you to enforce the rules. And so if they make a 4-sided die and they set the weights to be not 4, which they shouldn't do, then this code here handles it. So if the number of sides doesn't match the number of weights, then it makes the number of weights equal the number of sides and sets all of them to 1. It's like, no, we'll just even them all And then the third parameter is 10,000, and the 10,000 will go in for top. That's also invalid because this part here handles, it says, hey, does the number 10,000 appear anywhere on this 6-sided die? And it's going to go through it for every integer on the faces of the die. Did it find it? If it found it, set this Boolean to be true. Nope, it didn't find it. And so that Boolean is going to be false. And so what it's going to do is, because it's false, it will set the top to be just the first value of the sides vector. In that case, it'll set it to be 1. And so all this stuff is just error handling. Okay? All that stuff's just error handling. You know, this line of code, this line of code, and this line of code are what you need. Okay. Can you run the program to see what happens? Yeah, sure. Let me get rid of Bowser. And there you go. Absolutely nothing happens. Why? Because we have successfully created 3 dice and have done nothing with it. We have made 3 dice and made nothing with it. So we need to do things with it, right? So all we've done right now is initialize it, right? All we've done right now is initialize it. So we need to do things with it. So the next step you make is to do getters and setters. So step 1 of making a class, make constructors. Step 2 of making a class, make yo getters and setters. Okay? And in this case, I'm not going to make any setters because I don't think dice should change. Right? So I'm only going to have getters. Right? Maybe not even that. Maybe just 1 getter. The only thing I think that the user should be able to tell about the die after die is made is what's on top. Right? You know, maybe you'll play a game where you need to know what's on the other sides of the dice, but you know, honestly, all you need to know from a die after you've rolled it is what's on top. And so I'm going to say int get top, and it's going to just return top. There's no law saying you have to have getters and setters for everything. There's no law. I don't think main should be able to change what's on top of the die. The die, you know, like, he should be able to roll it, but I don't think he should be able to say, oh, the top number is 90,000. The only thing that I think main should be able to do is roll the die and see what's on top. Okay? So step 3, so that's our getters and setters. Normally we would be like get sides, get weight, set weight, get top, set top. And in this case, the only time I think that the faces of the die should be set, or the weights of the die should be set, is when it's made, right? Like, I'm going to put down an 8-sided die, and all the faces are 20s, right? That's the only time I think you should be able to initialize it. Now, you could disagree with me, and maybe when you make your die class, you want to allow the user to paint numbers on the die. Maybe that's your game. There's games like that, in which you can actually modify the dice in real time and click new faces onto the die. It's actually kind of a fun game. It's called Dice Forge or Dice Foundry, something like that. It's kind of a fun board game. You literally pop the faces off a die and click a new thing on. It's kind of fun. Range-based for loops are also modern C++, and they allow you to write code very concisely and readably. So in English, you would say for every face on the die, if that face matches what the user wants to be the top, then say that we found it successfully. Okay, and so it's going to go. It's basically looking at every face of the die. Like, the user is passed in, like, I want the top number to be 6, and so you have to look at the die and be like, is there a 6 on here? You go through every face on the die, and you're like, oh yeah, there is a 6 right there. Cool. If we found it, so it sets the top of the die to be 6. But let's say they set the top of the die to be -2. You look at every face. Nope, there's no -2. And so we just set the top of the die to be whichever one they passed in first. It's a little bit of error handling. Okay. Yeah, so the question is, will you be at a school that uses modern C++? Companies, no. Some companies are still using C. C is technically more popular than C++. C is a more commonly used language than C++. And so you kind of need to know the old stuff, but I don't like teaching it because it's harder, Old C++, 1998. Some universities mandate you use that and will penalize you if you use modern C++. Mostly, I don't know, because I think the professors don't know it. But I like it. Modern C++ is nice. It's really nice. Night and day different from old C++. Is it hard to learn different languages? No. Once you've spent this year learning C++, when you learn your next computer language, like Java, let's say, all you have to do is learn the differences between Java and C++. And there's differences, but it's not nearly as big as learning all of this stuff from scratch. Because Java has constructors. Java has range-based for loops. Java has ints and floats, and I don't know if they have floats. And yeah, ints and doubles. They don't have some of the types. They don't have unsigned integers, for example. But that would be a difference, right? Java ends every line with a semicolon, but Java does not end a class with a semicolon. And so all you have to do to learn Java is learn the difference between C++ and Java. So learning Java takes a year. Learning C++ takes a year. But if you know C++, you can learn Java in about a week. And if you know Java, you can learn C++ in a couple weeks. So, and then after you've learned a couple languages, then the next one gets even easier. And the next, learning C#. If you know C++ and Java, learning C# is a snap. C#'s a nice language. Python is super easy to learn. Last semester, I had my CSCI 1 students learn Python. So Python's a beginner's language that a lot of people like and use. There's nothing wrong with it, but it's really an easy to learn language. Python people have a harder time learning C++. Haskell, I'm not. I don't know Haskell. Okay. Now there are languages. So Jazz, to answer your question, there are some languages that are not easy to learn. What would be a good example? There's, of course, the Shakespeare programming language. The Shakespeare programming language, of course, which allows you to make variables, function calls. Here's Hello World. Romeo, a young man with remarkable patience. Juliet, a likewise young woman of... This is Hello World, by the way. Act 1, Hamlet's insults and flattery. Scene 1, the insulting of Romeo. Enter Hamlet and Romeo. Hamlet, you lying, stupid, fatherless, big, smelly, half-witted coward. Speak your mind. Speak your mind is their print command. Speak your mind. Speak your mind. And so, yeah. So this is Hello World in the Shakespeare programming language. So, not all of them are easy to learn. There are a bunch of languages that are deliberately obtuse. Let's see. Here's Hello World. Here's Hello World in Brainfuck. That's the name of the language. That's the name of the language. And it's deliberately designed to be obtuse. So. Yeah. But, the top languages are C, C++, Python, Java, C#. I don't know what else off the top of my head. Somebody's out there probably getting mad at me for not mentioning Ruby or PHP or whatever. But Swift, Objective-C. Okay, JavaScript. Oh yeah, JavaScript, of course. How could I forget JavaScript? Because I try to. Okay, so step 3 in making a class is the functions that actually do stuff. So functions that actually do cool stuff. Okay, so what is the main thing we do with the die? When you do dice, what is the one thing you guys think of? What's the stuff, the cool stuff we do with the die? Exactly. Yeet. Roll the die, right? Randomly roll the die. Okay. And so let's have, let's just do this the old-fashioned way. There's a better way of doing random numbers, but it's not worth getting into right now. Okay, so let's pick a side, and side is equal to sides dot at rand modulus sides dot size. Actually, let's do this. Okay, so this will pick a random side. We're not using weights. This is just evenly weighted right now. So we're going to pick a random side of the thing, and then we will return sides dot at side. Okay. So if we have a 6-sided die, this will return a I deleted the rand. There we go. So this will pick a random side. Okay. So if you have six sides on the die, this will return a number from 0 to 5. And we just feed that into the vector, pull that face out, return 8 or 10 or 20 or whatever. Okay. And you can combine this into one line, which I did originally, but this might be a little easier to understand. Okay, so shouldn't we set top to be that? Yes. Yes. Good call. Good call. Do you guys know what this means? So this is going to set top equal to sides dot at side. But when you do the single equals command, it actually returns the value that was set. And so this will both set top equal to sides dot at side and also return the same value. And so you can, this might help you guys understand it a little bit more. So it's the single equals actually returns the value that was assigned. And that's the reason for that is so you can do like x equals y equals 0, right? So what happens is it sets y equal to 0, and then x gets set to the value that was returned by y equals 0, and then it sets x to be 0. That's why it works that way. So you can chain together equals. Okay, so the only other thing we need to do is the weight function. Do you guys want to see that? We got 13 minutes left in class. I kind of want to get into the homework. Or do you want to see the weight function? So this is going to say for every weight in the weights vector, add it to the total. Assert total is bigger than 0, right? Somebody could feasibly pass in all zeros, which would be bad. And then we will roll a random. So rather than this, we will roll. So if you have weights of all ones, this will be functionally the same thing. But if one face is weighted more than another, then the total will be bigger. And what we do is we say for how do we do this? Yeah, let's just do this again. Total minus equal side minus equals x. If total is less than or equal to 0, return So, yeah. A little bit more complicated. What it's going to do is, if you have a total number of weights of 10, it's going to go through one weight at a time, subtracting the weights out. You randomly roll, and then it subtracts one weight out at a time, and once the number you rolled side needs to be less than or equal to 0. Side less than or equal to 0. Once you roll around, like let's say it's just an even die roll. Then what's going to happen is it's going to go through every face, subtracting out the weight of that face, subtracting 1 every time, subtracting 1 every time from whatever you rolled. You're going to roll a number from 0 to 5, and every time you go through it, it subtracts 1. And that should be probably plus 1, I think. Or it should be less than 0. It should be less than 0. Either way. So it subtracts 1, subtracts 1, subtracts 1. So let's say we roll a 3, which corresponds to index 4, right? The first time through this loop, we subtract 1. The next time through the loop, we subtract... next time through the loop, we subtract 1. Next time through the loop, we subtract 1. And then we're done. And so it'll return index 3, which is the number 4. Why do you use size t for index? Because anytime you index into a vector, that's a size t. It's an unsigned integer. That's the proper type to use. Anytime you use .at, you can use an int, but you shouldn't use an int. It should be a size t, because there are no negative indexes and indices in a vertex. Okay, all right. So let's talk about the homework. So that let's see it work. Jazz wanted to see it work. Let's see it work. So let's roll from Daisy. Cout Daisy dot roll, and now I get to see if this complicated thing actually works right. Daisy, yeah, let's do this. For int I equals 0, I is less than 5, I plus plus, cout Daisy dot roll. Okay, so 5 times we're going to roll Daisy's dice. So we got 1 4 and 4 3s. So cool, it's working. Let's do dry bones as roll. Six 6 1 1 6 1 6 1 6 1. Yeah, so there you go. That's a dice class. Okay, so let's talk about the homework. We got 8 minutes left. Your next homework is called Fractionation. It's a Janet Jackson reference. And okay, cool. What you will notice about this homework assignment to begin with is that there is no main.cc. You are probably in the habit of editing main.cc. Guess what? There is no main.cc. Main is in this file right here called do not edit me. And the reason why it's called do not edit me is because you shouldn't edit it. Okay. Don't edit it. If you edit it, you'll get a 0. Can't edit it. You can look at it. Can't edit it. So you can look at it. You can look at it. If you want to use Vim in read-only mode, use View. View is a version of Vim that is read-only, so you can't edit it by mistake. Okay. Warning: do not modify this file at all. If you modify it, you'll get a 0. Okay. So here's main. It's main, and all it's going to do, it's going to call your function, the stuff that you write. And so what you're going to be doing for this assignment is you are going to be writing a class, like what we just did in class today. Class today. And you're going to be making a fraction class. So this is essentially the exact same homework assignment you did last time with the Egyptian fractions and all that kind of stuff, but you're doing it the quote-unquote proper way this time. Okay? And to enforce that you're doing it the proper way, you can't modify main. Main is done. Don't touch it. After all the homeworks are collected, what I'm going to do is search through everyone's submissions and see if any of their files are different. And so I have a very easy way of seeing if anybody modifies main. Okay? Or the make file, for that matter. So what main does is it just makes a fraction. So the user is going to type in a fraction just like what we had before, right? 3/5 means 3/5, right? 0, 0 to quit. It's the exact same as before. And it's going to make a fraction. And look at this. Look at this. Do you guys see that? This is your class, fraction. And you can just CNN into it. CNN. No, not the garbage news channel. CNN into it. Okay? You can use the stream extraction operator. Last time I got stream extraction, stream insertion backwards. This is the stream extraction operator. The other one's the stream insertion operator. So you're going to CNN into it. And so how does that work? How is it possible that C++ knows what it means to CN into this class you made? Well, let's go into fraction.h and find out. And if we scroll around, you can see that there is, in fact, if we scroll around, we can see that there is, in fact, there it is. You can see, in fact, there is a operator double right arrow. So operator double right arrow is a special function. It's a special function. It's not technically I mean, it is technically a function named operator double right arrow. It's technically named that. But when C++ sees a function named operator something, then that allows you to write code like this, where you just say CN into F. And so anytime there's an operator, like plus is an operator, minus, times, anytime C++ sees an operator with a class, it looks for a function named operate, like literally typing out operator and then that operator. And so because C++ knows what this function is, it sees this function, and this function takes an iStream. The type of CN is iStream. iStream, uStream, we all stream for iStream. Because it sees a function with the double right arrow operator and fraction on the right side and iStream on the left side, it's like, oh, I know how to do that. I get that reference. So this code will actually work. And what it will do is it will call this code here. It'll call this code here. This code is technically not part of your class. You might notice the word friend. This code is not technically part of your class. Normally people write the double right arrow operator outside of the class, but you can put it inside as well. Yeah, it's a little less typing this way. So do we need to add a space here? No, spaces are ignored by C++. If you wanted, you could you can erase the spaces. It'll compile fine. It just kind of looks like, I don't like it. I don't like the look. It's just a style thing. I'm not one of those professors that marks you down on style. Yeah. You can erase the space if you want. The only time spaces matter is like in strings. You know, if you put extra spaces in a string, then you'll have extra spaces. So this code works. This code is done for you. Okay? This code works. It's done for you. You don't need to modify this. It's done. So in main, where it's saying CN double right arrow into F, it is done. And what it does is it reads from CN. CN gets passed in as ends. CN gets passed in as a parameter. And CN will read from the keyboard and put the first number into num, numerator, and the second number into den, the denominator. And then it returns CN. You need to, for this assignment, what you're going to be doing is looking at examples that I have made. For example, I've done operator plus for you, and you have to look at my code for operator plus and make operator minus. And I'll just warn you guys right now, you should change one letter. Oh, sorry, wrong one. one character should be changed between operator plus and operator minus, and you'll be done with it. Okay? What I'm trying to teach you guys with this assignment is looking at existing code that works and being like, okay, that's how that works. I see. Or maybe I don't see. But I know that in order to make operator minus, all I need to do is change a plus to a minus, copy, paste, change a plus to a minus, and I'm done. And then I can test it, and it works. Okay? So that's kind of the big brain move that you guys should be making on this assignment. So I have done operator double right arrow for you. You have to write operator double left arrow. So I've got input working for you, and you need to, kind of gaze lovingly at my beautiful, wonderful example code, which doesn't do any error checking, and it's actually kind of garbage. But whatever. I made it as simple as possible. Look at my example code, and then be like, Maybe that is not actually how a fraction should be printed to the screen. Maybe that line of code is wrong. Is there an input tester? Yeah. Or maybe there's not. I don't know. I'll put one up. So, what is the command to exit Vim without saving? It is :Q! Yeah, so this is a line from Fist of the North Star, of course. We're studying to die in Japanese right now, which adequately describes our experience in Japanese. I've been studying like hours every day for it. All right, so look at this code, and then, remember, the arrows are going to turn around. Flip that frown upside down. So rather than double right arrows, you can have double left arrows. And you're going to be outputting the numerator, followed by a slash, followed by the denominator. And that's it. And that's the first thing you should do, because you are not going to be able to debug any of your code when every time you try printing out the result of a fraction addition, it says omae wa mo shinderu, right? If it prints that every time you try to see if your code's working, you're gonna have a bad time. This is the first thing you should do. This is the absolute first thing you should do. Is I give you something very close to the right answer here, except it should not be cout. Okay, don't use cout. Outs. Cout is passed in, so you should be writing to outs, not cout. Okay. And then getters and setters are already done for you. That's done for you. You need to write a constructor. You need to write a constructor for it. And hopefully with the lecture today, this does not need to be anywhere near as complicated as what we had today with the dice class. This class is just a numerator and a denominator. There is a class invariant. So there is a rule for this assignment that the numerator and denominator must always be over 0. And the reason for this is because this is really a fraction to be doing Egyptian fractions with, and Egyptian fractions always have to be not even just non-zero, but positive, right? You can't do Egyptian fractions with negative numbers. I mean, I guess you could, but what's the point? So if we come down here, you can see that there is a function called operator plus defined, and that allows you to write code that says, like if you have a fraction a and a fraction b, you could say a is equal to a plus b. Cool, that's really neat. You can just write code that looks very nice and very simple, and it does the fraction addition the way that you think that fraction addition should work. 3/10 plus 2/10 will be 5/10. And so what this code does is that it takes in b, essentially the right hand side of the operator. Here's the operator. The left hand side is a, the right hand side is b. Me, us, num is the left hand side. We're the left hand side, and then the right hand side gets passed in. So this is the left hand side. We are the left hand side, and then the right hand side is passed into us. So a that's a's num, and then if you want to specify b's num, you have to say b.num. So just num by itself is a's, and the right hand side you have to say b.num. And so this converts to a common denominator. It converts the fractions to a common denominator, and then it adds our numerator plus their numerator together over the common denominator, and it makes a new fraction that way. And then it just returns it. If you wanted, you could do this even more succinctly by just using the curly brace syntax that we showed earlier. But for now, I would just do it like that, or not. It's up to you. It's your life. But you could just put, like, if you wanted to return like 3/5, you could do that. That would return 3/5. So you don't have to go to this rigmarole of creating a return value and returning the return value. You can actually just put the num here and the denominator here, the numerator here and the denominator here, in curly braces. That would work too. So, did he post code from lectures that we can view and study later on? Sure. I will. This is all the code that you have already. I will put the dice code up. Move main.cc into the public directory into die. We'll call it dice so people know what it is. And so if you guys want to get a copy of the code from today, what you're going to do is type copy, cp is the copy command. Copy /public/dice.cc into your home directory. Okay, so or wherever you want to put it, but it'll just go into your home directory, and I'll put that in the Discord channel. So if you just type that, then when you type ls, you will see that there is. You'll see that somewhere in here there is a. Oh, I already moved it, but you'll see in your home directory there is a file called dice.cc. Okay. Do we need to know math in order to code? You have to understand fractions. I'm just going to throw that out there. It had been ages before I'd done fractions, and I'm like, dividing fractions. You just flip it over, right? You know. And so what you guys are going to find is that fraction multiplication is very easy. The two numerators and the two denominators multiply by each other. Two numerators are the new numerator. Two denominators multiply together is the new denominator. Done. Division's the exact same, except the second one's numerator and denominator are flipped. Subtraction is the same as addition, except the plus turns into a minus. I'm just going to give that one to you guys. So when you guys write this code, just start with my operator plus, copy and paste the code into operator minus, change the plus into a minus, and you are done. Test your code. Test your code. And if you test your code and it says omae wa shinderu, you haven't done the operator double left arrow yet. You have to code and do math? Yeah. You got to know fractions. Intermediate algebra is I think this class requires trig, right? So we do some stuff with sines and cosines and stuff like that. Not often. When will we learn big O? We will learn big O soonish. I want to go through the class stuff first, though. I really want to make sure you guys have a solid foundation on classes, and that's the topic for this week, really. And then after that, we're going to start talking about the standard library and big O and stuff like that. So your math will actually make things that are useful. Yeah. All right, so that's it for today, guys. This homework assignment's due next Monday, so you got plenty of time to do it. It should be pretty easy. Most of it is going to be copying and pasting my code and then changing it to work. And that's again the big brain thing, that you can look at code that works and modify it to meet your needs, because that's how real programmers do coding. You find examples online and modify it for your needs. All right, guys. Flight was delayed because my equations raised terror fears. That's too funny. A lot of people with what's it called, math phobia or whatever, are like, no, not a differential equation. I can't go on the flight. That's funny. Office hours today. Office hours today are over. But come by office hours tomorrow. Just send me a message on Discord, and I'll set up a time with you on Discord. Office hours are 11 to 12 every day. Okay. All right. Thanks, you guys. Peace out.